Hello friends, today we solve problem on graphical analysis. So let's start. So in our previous video, we study what is a graphical analysis or what is a different kind of motion curve. So here is a problem. A car moves along a straight road such that its velocity described by graph as shown in figure. So in this question it is a VT curve. Okay. For the first 10 seconds, the velocity variation is parabolic. So they mention in the question, initial 10 seconds, the variation in velocity is parabolic. Means it is a parabolic curve. Okay. Then at between 10 to 30 seconds, its variation is linear. So we can see here in a graph. Construct the ST curve, position time curve or displacement time curve, and AT curve, acceleration and acceleration time curve for the time period 0 to 30 seconds. Okay. So here's a problem. So we have to construct ST curve and AT curve. Okay. In our previous video, in brief, we study from VT curve, we can find out acceleration and new position of the particle. To find the acceleration, we just find slope on the VT curve, and to find the position, we use this formula, that is final position of the displacement is final position of the particle is equal to initial position of particle plus area under the curve VT. Okay. So in this question, we have to find both the curves, that displacement time curve and acceleration time curve. So for the acceleration, we have to find the slope on this curve, and for the displacement time, we use that formula. Okay. So let's start with the problem. So here is a diagram. Okay. Here is a graph, VT graph. From VT graph, we have to find acceleration time and displacement time curve. So in question, they mention it is a parabolic in nature. This curve is a parabolic in nature, and this curve is a straight line. Okay. So we have to first we find the acceleration of this curve. Okay. Acceleration time curve. Acceleration time. So for acceleration time curve, we have to find just slope on that curve. For slope on that curve, we just differentiate the equation and we get slope. Okay. Here, if we see, we have to find the slope on this curve. So it is not a straight line. If it is a straight line, we can use 2-point form to find the slope. Here is a curve, so we use differentiation form, application of differentiation. That is, if we know the equation of this curve, we just simply differentiate this equation, we get slope at any point on this curve. So we have to first find out the equation of this curve. Okay. So in question, they mention for 0 to 10 second, VT curve is parabola. Okay. So it is a parabola which is passing through origin and an upside parabola. So we know the equation of this parabola, that is general equation, y is equal to kx square. Okay. So here on y-axis, in our diagram, in y-axis there is a velocity, on our x-axis it is a time. So we just substitute here, we get the equation of this curve. So equation of curve becomes v is equal to kt square. This is our equation. So here k is a constant, we have to find the k first. Okay. So from diagram we can find out the value of k. Just like at a time t, the velocity of the particle or velocity of car is 0. Okay, when time reaches 10 seconds, the velocity of car is 100 meter per second. So we get the conditions. So just substitute at t is equal to 10 seconds, v is equal to 100 meter per second. Okay, if we substitute this value, we get answer of k, that is 100 is equal to k t square. We get answer k is equal to 1. So equation 1 becomes v is equal to t square. Okay, so we get the equation of this vt curve for time interval 0 to t second. So here we have find at curve. We have to find at curve. So first, a motion from 0 to 10 second. So now we have find the acceleration when t is equal to 10 second. Acceleration when t is equal to 10 second. So from vt curve we have to find acceleration. So we have to just find out the slope when t is equal to 10 second. So for the to find the slope we use application of derivative, that is okay. We know the equation of velocity, that is t square. If you solve this, we get answer 2t. We have to find the acceleration when t is equal to 10 seconds. Then this acceleration becomes acceleration when t is equal to 10 seconds is 20. Unit is meter per second square. Okay. Now we consider motion from 10 to 30 seconds. Second part. So here we have this VT curve and we have to find the slope of this inclined line. So we just use 2-point form. Okay. So for coordinates of this point is 10, 100 and coordinates of this point is 30, 500. Okay. From these 2 points we can find out the slope of this inclined straight line. So acceleration at t is equal to 30, we use 2-point form, that is y2 minus y1 divided by x2 minus x1. So here x1 y1 is 10, 100 and x2 y2 is 30, 500. Okay, just substitute here, we get so from graph VT graph we can say the rate of change of velocity of car is constant. So therefore the acceleration of this car is a constant. So at a t is equal to 20 seconds, the acceleration of car is 20 meter per second square. Then any point on this curve, the acceleration of the car is the same, that is 20 meter per second. So let's draw the graph. AT curve. So This is a VT, here is a VT curve, and here VT from time interval 0 to 10 second. The nature of curve is parabola, and it is an increasing function curve, increasing slope. Here it is an increasing slope with a constant rate. Okay, then acceleration of the car will be straight incline. Okay, here the rate of change of car for the time interval 10 to 30 seconds, the rate of change of velocity of a car is a constant, means the acceleration of the car is a constant between time interval 10 to 30 seconds. Therefore, the nature of curve AT is a horizontal straight line. Okay, this is our AT curve. In question, they also say to find the displacement time curve. So let's start with the displacement time curve. So we have VT curve. We find the acceleration using this formula, that is dv by dt, and slope on the curve Vt. Now we have to find the position and displacement of the particle. So we use this formula, that is final position of particle is equal to initial position of particle plus area under the curve. So we have formula, that is xf is equal to xi plus area under the curve. Okay, so let's start the position of the particle when t is equal to 0 seconds, when t is equal to 10 seconds, and when t is equal to 30 seconds. Okay, so first, when t is equal to 0 seconds, when t is equal to 0 second, the displacement of particle is 0, that is x0 is equal to 0 meter. Okay, then when t is equal to 10 seconds, next point. So our formula is xf is equal to xi plus area under the curve, area under the Vt curve. If we see this curve, it is not a regular shape like triangle or rectangle, it is a curve. So we have to find the area under this curve. So we use application of integration to find the area under this curve. So we have to find, so we find out the position of the particle when time is equal to 0 second. Now we find the position of particle when time is equal to 10 seconds. Okay, so to find the position of the particle, we from Vt curve we use the formula, that is xf is equal to xi plus area under the Vt curve. If we see this diagram, this is not a standard shape like rectangle or triangle, this is a curve. So we have to find the area under this curve. Okay, so we have to find the area under this curve. So we use application of integration to find the area under this curve. Okay, so we have formula, that is xf is equal to xi plus area under the curve. So here xi, the initial position of particle is x naught, which is 0 meter. Okay, we have to find xf, means position of particle when t is equal to 10 seconds, that is x10 is equal to x0 plus area under the curve. So here this is not a regular shape like triangle or rectangle, so we have to find the area under this curve. So we use the application of integration, that is x0 is equal to 0 plus integration of equation of this curve is y is equal to t square. So we use t square with respect to dt, and the t varies from 0 to 10 seconds. So we simply substitute upper limit, lower limit is 0 and upper limit is 10. Okay, so we use this formula. Okay, so just calculate 0 plus integration of t square is equal to t cube by 3. Lower limit is 0, upper limit is 10. Substitute here, we get answer, that is 333.33 meter. Okay, so we get answer when t is equal to 10 seconds, the position of the car is 333.33 meter. Okay, now we have to find the position of the particle when t is equal to 30 seconds. When t is equal to 30 seconds. So we have formula, that is xf is equal to xi plus area under the curve. So here we use this time interval from 10 to 30 seconds. Then the initial position of the particle will be when t is equal to 10 seconds. The initial position of particle is x10, which is 333.33. If we take the time interval 0 to 30 seconds, then the initial position of the particle will be x0, that is a 0 meter. So we use this time interval from 10 to 30 seconds. Okay, from 10 to 30 seconds, here there is a two shape. Okay, one is a triangle, another is a rectangle. So we have to find the area under this curve. Okay, so let's start. So for time interval, we use for time interval t is equal to 10 to 30 seconds. Here initial position of the particle is x10, which is 333.33 meter. Okay, if we use the time interval 0 to 30 seconds, then the initial position of the particle will be x0, that is 0 meter, and we have to consider overall area. So we have to find the final position, that is xf. So we use x30 is equal to x10 plus area under the curve. So here x10 is 333.33. Okay, and we have to find the area under the curve. If we see here there is a two regular shape. First is a triangle, second is a rectangle. So we have to find the base and height of the triangle and rectangle first. So here the base of triangle or rectangle is 30 minus 10, that is 20. Okay, height of the rectangle is 0 to 100 means 100. Okay, and height of the triangle is 500 minus 100, that is 400. Okay, so let's find out the area under the curve. There is a two-step shape. First is a triangle. So triangle base is 20, base is the 20 and height is a 400. Plus there is another shape which is a rectangle. So base of the rectangle is 20 and height of the rectangle is 100. If we solve this, we get answer. So we get answer, displacement of the particle or position of the particle when t is equal to 30 seconds is 6333.33. Okay, so now we have to construct a graph. Okay, so here VT curve for the time interval 0 to 10 seconds. The nature of curve is parabola. Okay, so we have So we have three standard motion. First is a uniform velocity motion, second is a uniform acceleration motion, and third is a variable acceleration motion. So in the question, here Vt curve, for the time interval 0 to 10 seconds, the nature of curve is a parabola. If we see for the variable acceleration motion, the nature of the curve for the Vt is a parabola, and we have to construct a displacement position time curve. So from parabola we get cubic. So for the time interval 0 to 10 seconds, the nature of curve is a cubic. Okay. For the time interval 0 to 30 seconds, the nature of curve is inclined straight line. Okay. So if we see the standard motion curve for the uniform acceleration motion, the nature of the Vt curve is inclined straight line. Then the nature of the Xt curve will be standard, so parabolic in nature. So we draw parabola here. So we get the final answer. This is the Xt curve and this is our At curve. Okay, we construct both the curve, At curve and Xt curve. So this is our final answer. Thank you. If you like my video, please like, share and subscribe our channel. Thank you.